Hello, my name is Lee, and I'm a Genomics and Life Sciences Specialist here at AWS. In this video, I'm going to give you a quick demonstration of running Cromwell on AWS. If you haven't already, I recommend that you watch our webinar that goes into the details of genomics workflows, patterns and services, and how to use Cromwell. As we covered in our webinar, here are key considerations when working with genomic data. First, genomic data sets are big. Depending on the amount of detail, a single genomics experiment can range from tens of gigabytes to several petabytes. Second, converting raw DNA sequencer data to scientific insight takes a lot of computational steps, each with their own unique resource requirements. Handling genomic data involves processing pipelines or workflows. So for example, here is the Broad's Genome Analysis Best Practices workflow. As you can see, there are many steps to get to the data that scientists would use for analysis. This is where Cromwell comes into play. Cromwell is an open source workflow orchestration engine that runs both on local machines and in the cloud. Cromwell reads workflow definitions written in languages like WDL or WDL and CWL, and then launches the resources needed to run the jobs defined. With AWS, Cromwell acts as an interface to AWS Batch. Workflow jobs are submitted to batch queues and run on batch compute environments. In the next few minutes, I'm going to walk you through setting up Cromwell on AWS and running a simple workflow. To start, you're going to need the following things: an EC2 instance to serve as your Cromwell server, a custom AMI for running genomic workflow jobs and talking with Cromwell, an S3 bucket for workflow inputs and outputs, and a batch compute environment and job queue. The first thing you're going to want to do is create a custom AMI. If you go to our website on Genomics Workflows on AWS, you can find instructions on how to get the Python script that generates the custom AMI and how to run it. In a terminal, you can run the Python script, specifying your region, and using the Cromwell Genomics AMI cloud init configuration file. The script takes about 5 to 10 minutes to complete. When the script completes, copy the AMI ID. You're going to use this AMI when you create your batch compute environment. To create the remaining resources you need, you can use the CloudFormation stacks that we've provided in our Genomics Workflows documentation. You can either use the full stack, which creates your S3 bucket, VPC, IAM roles, and batch job queue and compute environments, or you can use a CloudFormation template that will launch these resources in an existing VPC, or you can use individual templates for creating the S3 bucket by itself, IAM roles, and the AWS Batch environment independently. To use these, simply click on the button, click Next, specify your AWS bucket, key pair, availability zones, and provide the AMI ID. Use the AMI ID that you created using the custom AMI script. Hit Next, and Next again to create your infrastructure. When your infrastructure is complete, go to the batch stack, go to Outputs, and record or take note of the 2 job queues that were created. In this walkthrough, we're going to use the high priority job queue. Copy this value for later. In the EC2 console, create an instance that you will use for your Cromwell server. When the instance is up and running, connect to it. Once you connect to your server, download the most recent version of Cromwell. And create a config file. Replace the placeholders for S3 bucket and batch QARN. Create the following files: a hello WDL file with a single task called hello and a workflow wf_hello that calls that task. This task will simply echo the command hello and addressee welcome to Cromwell on AWS. It'll use another file for inputs. In this input file, put this JSON formatted data: wf hello.hello.addressee and world. You may now start the Cromwell server on your EC2 instance. In this case, I'm using an SSH tunnel between my local machine and the remote instance on port 8000. So I can navigate in a web browser to localhost port 8000 and see Cromwell's Swagger UI. We can use this to submit the workflow that we created in the previous step. While this workflow runs, you can monitor its status in the logs or via the AWS Batch console. Here you see one job has been submitted and is in the runnable state. You should see that the desired CPU count increases when the job is ready to start, and that in the EC2 instance or in EC2 management console, you should see instances queuing up. When the workflow successfully completes, you should receive a notification. And you should be able to see successful completion in the logs. You should also be able to find outputs that the workflow generated in your S3 bucket. Well, that concludes the demo. If you'd like to learn more, I recommend checking out the docs for Cromwell and running genomic workflows on AWS, taking a look at Cromwell's GitHub repository, and looking at what you can do with WDL at openwdl.org. If you'd like to learn more about other scientific workloads on AWS, I recommend you check out our pages on research and technical computing. Take a look at our Research Cloud and Cloud Credits for Research Programs, and explore datasets we host on our registry of open data. That's it. Thank you very much, and go build.